This is a short video about differentiating powers. The rule that we're going to be using is this one. So d dx, which is an operator, it just means differentiate with respect to x, whatever is here. So for a power of x, we multiply by the old power and take 1 away from the old power as well. So we'll apply that to some examples. In the first case, we've got to differentiate x to the power of 7. So this is a simple case of taking 1 from the power, so it's going to give us x to the power of 6, and we multiply by the old power, which is 7. So the derivative of x to the 7 is 7x to the power 6. In the next case, it might not be obvious what the power is, but x, we could write that as just x to the power of 1. So if we want to apply the rule to it, we're going to have 1x to the power of 0. Now x to the power of 0 is just 1, so that leaves us with 1 times 1, which is just 1. In practice, it's probably something you would just remember. You wouldn't apply this every time you see x. So just remember that the gradient or the derivative of x is 1. In the next example, we've got 5x to the power of 3. The rules of differentiation say that because we've got a 5 here, we can take that outside of the operator. So it just means that we're going to just differentiate x to the power of 3 and multiply the end result by 5. So when we differentiate, we'll get 5, and then we differentiate that part. So it's going to be 3x to the power of 2. So simplifying that gives us 15x squared. 1 over x squared, if we want to apply the rule, we've got to write it in the form of x to the power something. So we'd have to express 1 over x squared as x to the power negative 2. Then we can apply the rule. So this is going to be minus 2x to the power negative 3. The final example is probably the one where students often make a mistake with this. We've got a common factor of 1 over 4. So the first thing we should do is take that outside of the differentiation. So it means when we've now got 1 over x cubed in here, which is the same as x to the power minus 3. So make sure you can see how to get from here to here. Then we just apply the rule as normal, so it's going to be 1/4, it's going to be minus 3x to the minus 4, and you could simplify that a little to give you minus 3/4 x to the power negative 4. Finally, we'll look at some examples where we have fractional powers of x. So we'll deal with these in the same way as before. So with x to the power 5 over 2, if we reduce the power by 1, it will give us x to the power 3 over 2, and we multiply by the old power, which is 5 over 2. This example, we've got square root of x, but square root of x, you can write it in index form as x to the power of a half. So when you differentiate that, you're going to get a half x to the power negative half. So you could leave it like that, or if you want to change it back into root form, you could write this as 1 over 2 root x. In the final example, we've got a cube root in the denominator of the expression. So before we begin, we're going to write it as a power of x. So we can change this to be 4x to the power negative 1/3. And now we can differentiate. So if we do that, the 4 will just multiply the derivative of that bit. So if we differentiate, we get minus 1 over 3. It will be x to the power minus 4 over 3. So we could simplify that a little bit. So maybe we could write the answer as minus 4 over 3 x to the power minus 4 over 3. If you want to change it back into root form, well, it's going to be like this. we're going to have negative. It will be 4 divided by 3. Now x to the power 4 over 3 is like the cube root of x to the power of 4. So the final answer would be written like that.